differences are the same, what type of function do I have? Linear, quadratic, cubic, quintic, linear. So the first point is, if the first differences are the same, then my function is linear. And we know that my function being linear is just literally a graph that has a line. Now, if my first differences are not the same, we then have to do something called the second differences. When the second differences are the same, that means that my graph is quadratic. So I have a graph that looks like this. It's one of those U graphs that I have. Yep. You don't have it? No. You sure? Yeah. You lying to me? No, I'm joking. Here. However, if your second differences fail and they're all different, that means you don't have a linear or quadratic function and you can just write neither. So the way you do your first differences is you work from bottom up. Okay, so you take the bottom number and subtract it from the number on top of it. So the first one we have is 0. We have this table of values over here. So I'm going to do my first differences. So we're going to start from the bottom and then go up and subtract. So I have 8 minus 7. What does that give me? 1. So the rule is subtract bottom number from top number. Okay, what is 7 minus 6? 1. They're all 1. So what type of graph do I have? Linear. Therefore, this function is linear. Okay. Simple stuff, right? Okay. Now let's try our next one. So I have B. So again, I'm going to label a column called the first differences. Start from the bottom and go up. So 7 minus 5, what does that give me? 2. 5 minus 3. 3 minus 1 is 2. And now what is 1 minus negative 1? 2. Remember, when you have two negatives together like this, it becomes addition. So it becomes 1 plus 1, and that gives me 2. So therefore, this is linear. Any questions so far? Or are you guys pretty good with this stuff? Pretty good so far? Okay. So now let's go work on C. So again, start with my first differences. Oh, you found the pages? Yeah. So again, bottom up. 19 minus 12. 12 minus 7. 7 minus 4. And 4 minus 3. 1. So my first differences are not the same. which means I need to move on to my second differences. So I'm going to move on to my second differences. So now we're going to be using the numbers from the first differences to help us figure out my second differences. So 7 minus 5, 2. 5 minus 3, 2. 3 minus 1 is 2. So if my second differences are the same, what kind of function do we have? Yep, this is quadratic. Yes, Jade?
What are the second differences from?
You would write neither. Because you guys don't learn about cubic or quintic functions yet. Well, you guys
Will
won't.
we ever learn
No.
another one? Okay, good.
If you're wondering what like a quintic function would look like, if you're ever wondering, I know one of you is probably wondering. This is what let me see. This is something to the power of 4. This is a function that has a power of 4 to it. So you guys are not doing this. This is for the grade 11 U's next year who are plan on taking advanced functions. So you guys don't have to worry about this. All right. So for C, I can tell you right away, or for D, I can tell you right away it's going to be neither, and it's a cubic function, only because I know it's a cubic function. So we will start again with D. So again, we'll start with my first differences and then work my way through process of elimination. So 64 minus 27, what does that give me? 27 minus 8. 8 minus 1 is 7. And then I get 1 minus 0, which is 1. So first differences are not the same. Therefore, I go on to my second differences. Okay. So I can already tell you guys this is the graph y is equal to x cubed. I can tell you that much right now. So 37 minus 19, 18. 19 minus 7, 12. And then I have 7 minus 1, 6. Okay. So because the second differences are not the same, what can we just write? Neither. Therefore, neither. So this graph, from my knowledge of math and all of that, this is the function y is equal to x cubed, which looks like this. Okay. But we're not going to be working with any cubic functions. So all we're doing with this course is just parabolas and u's. And then we're probably, we're most likely going to do trigonometry functions. You know, little waves, like sines? Yeah. That's stuff. Yep. So again, first differences are the same. Linear, second difference is the same. Quadratic. If second differences are not the same, you just put neither and you just leave it at that. We'll do E as our last one, and then you guys can do F on your own and use it as a warm-up before doing the homework. So E is first differences first. So 20 minus 12 gives me 8. 12 minus 6 is 6. 6 minus 2 is 4. And 2 minus 0 is going to be 2. So as you can see, my first differences are not the same, which means I need to move on to my second differences. So now we go again. 8 minus 6 gives me 2. 6 minus 4 gives me 2. And 4 minus 2 gives me 2. And because my second differences are the same, therefore, this graph is what? Quadratic. So like I said, I'm going to let you guys do F on your own after the lesson is done. I think I have one more page of stuff, I think. It's probably very repetitive, but c'est la vie. This one. Okay. No, we're not done yet. Oh, we're not doing that. You guys are doing that by yourself later. Oh, you did? What did you get? All right. So let's move on to the next page. So let's see if you guys remember how to make a linear problem. So to rent a car with Why Not Rent, it costs $1.25 per kilometer. The cost C of D in dollars is a function of the distance traveled, D in kilometers. So this is called function notation. So it's the variable, and so it's the dependent variable is the big letter. So C is your dependent because it's the cost. And your lowercase letter is going to be your independent variable. So it's basically read the cost in terms of time or in terms of distance gives me this. Yes, Emma?
How do we know what was dependent on?
So you would make sense. So in this case, we have cost and we have distance. Does the cost depend on the distance or does the distance depend on the cost? That is what, that's how you would read it. So in this case, my left side is going to be C of D. And who can come up with an equation for this word problem? So remember, the cost is $1.25 per kilometer. And we're saying that my distance is represented by D. Ashton. Mm-hmm. Yep. So 1.25, that is my rate of change. So now you guys are going to hear of a word. Yes, Rebecca? So in this case, my cost depends on the distance traveled. So like I said, your big letter, your uppercase letter is your dependent variable. So the C, which is cost. And your variable in brackets, so the lowercase, that is your independent variable, which is usually distance or time. So now we're going to learn about the degree of a function. Does anyone remember what that is? Camilla? Yep. Yep. So here we have, so when there's nothing on top of a variable, it's automatically 1. So my degree here is going to be 1. I have something that is x2, my degree is going to be 2. x3, my degree will be 3. Okay? In this case, my d has nothing on top of it, so what is my degree of the function? Jade? 1. And when my degree is 1, it means my function is linear. Therefore, it is linear.
Wait, why is it linear?
Because my degree is 1. Yes.
But where's the x? Would x be the d in this case?
So x would be the d in this case. So depending on the question, your x can change very. It can be D, H, I, J, K, any letter of the alphabet, to be completely honest with you. Now, use the function to calculate the cost of traveling 225 kilometers. Ashton, how would we do that? Yep. So sub for D. So we get C at 225 is equal to 1.25 times 225. So who can tell me what my cost is going to be? Ashton. 200 and what? Mm-hmm. So my therefore statement would be therefore it would cost $281.25 to travel 225 kilometers. Yep.
I didn't put like the C at the beginning of the equation. I just did the 1.25 times.
That's fine. I'll teach you guys, I think tomorrow, I'm going to teach you guys when to use that and when to not use that. Okay. So now we need to figure out my domain and my range. So what is the domain and the range of this function, assuming that you can only travel 500 kilometers on one full tank of gas? So what would my domain be? Let's see. So again, it's going to be XER, such that what is the minimum? It doesn't give me a minimum amount I have to travel, but what would the minimum amount be that you need to travel, realistically? Jade? That's the max. Max is 500. 0. So 0 is my minimum, 500 is my maximum, and D is my independent variable. So D has to be bigger than or equal to 0, but less than or equal to 500 kilometers, because that is the maximum I can travel on one tank of gas. Yep.
Sorry, so now we have for the equation, we have C times 2
Mhm.
to 225
Yep.
is 1.5. So would that mean that what are we going to do with C? Are we going to
So in this case, because I need to figure out how much it costs me to travel 500 kilometers, I need to sub in 500 for D and figure out how much it's going to cost me to travel 500 kilometers, because that's going to be my maximum.
So then what about C?
C?
Yeah.
We always solve for C. So this, you're never going to put a value in.
Okay.
So for my range, it's going to be YER. Okay. What's the lowest cost? What is the lowest thing that I can possibly be charged? It's the same thing as my domain. 0. So I can be charged $0 if I choose to get in the taxi and not go anywhere. The maximum, now I need to figure out how much it's going to cost me to travel 500 kilometers. So now I need to plug in 500 for D. So sub for D. Yeah. So I'm going to take C at 500 is equal to 1.25 times 500. And Ashton, what did you say it cost? 625? Which means that for a 500-kilometer trip, I have to pay a maximum of $625. So 625 is the most I am going to pay for traveling 500 kilometers on one full tank of gas. That is so expensive because gas, a full tank of gas, is more than 500 kilometers. So C has to be bigger than or equal to 0, but less than or equal to the value of $625. Does everyone understand that? Ish? You can come ask me after or watch the video again. I think we have one more question. Okay. So the last example is state the degree of the function and identify which one is linear and quadratic. So the degree of the function is the highest exponent in the function. You're not going to add all of the exponents. It is the highest exponent in that expression. So I'm going to give you guys a quick example to show you exactly what I mean. So what is my degree for the example I just put there? What is the highest exponent? Cynthia? 4. 4 is my highest, which means my degree is going to be 4. So for A, I have k of x is equal to 3x times x plus 1. Can you tell me the degree right away, or do I have to do something first? Pardon? Distribute. Right. So this is from grade 9, distributive property. So I need to multiply 3x by x. Can someone tell me what that gives me? Jade. 3. X what? X squared plus 3x. So what is the degree of this function? What is the highest exponent, Rita? 2. So if my exponent is 2, what type of relation do I have? Linear or quadratic? Quadratic. Okay. B is going to be a bit more tricky. So we have m of x is equal to x plus 2 squared minus x squared. So we're going to have to do something similar to example A. We have to expand. Does anyone remember how to expand that perfect square simply without doing it in 2 brackets? Does anyone remember? Okay, so I'll do it the long way, that's fine. So this squared up here means that I have 2 of these brackets over here. I have 2 brackets of x plus 2. I'm going to write x plus 2 times x plus 2 minus x squared. Do you guys remember how to FOIL from grade 10? Okay. So I'm going to start, yep. So I'm going to start with my first term, which is x, and I'm going to multiply it by the first term in the second bracket. So what is x squared? What is x times x? Now I'm going to take the first term of the bracket, which is x, and multiply it by the last term in the second bracket. What's x times 2? 2x. Now I'm going to take the last term in the first bracket and multiply it by the first term in the second bracket. 2 times x. Yep. And then Brooklyn, the last one, 2 times 2? 4. So now we're gonna collect like terms and simplify. So what are our like terms here? The two x's. Thank you, Omer. So two x's. Cynthia, what else? The x squared. And then 4 is by itself. So I'm going to get x squared minus x squared plus 2x plus 2x plus 4. So what is x squared minus x squared? It's 0. If you subtract the number by itself, it's going to give me 0. So these guys can cancel out. What is 2x plus 2x? Nope, just 4x. Nope, you don't add the x's. You only do x squared if it's being multiplied by each other. And then we're left with plus 4. So what is the degree of this equation? Sarah? 1. So what type of relation do I have? Linear. Yep. Ashton, what's up?
Did you expand without like creating brackets?
Yep, you can expand without creating two brackets. I will show you. You guys will probably have to watch this again later to remember. So if you guys hopefully remember from last year, when we have a binomial in a bracket and it's all squared, to avoid the whole two bracket thing, you're just going to square your first term, which is a. You're going to multiply a and b and multiply that by 2, and then square the last term. So in this case, I had x plus 2 squared. So let me just do this. So I'm going to do it without the two brackets. So if I square x, what do I get? X squared. So to get my second term, I need to multiply 2 by x and then multiply that whole thing by 2. So what's 2 times x? What's 2x times 2? And then what's 2 squared?
You just add the 2 in the bracket and then square it.
Yep. As you can see here, this 4x we got from 2x plus 2x. This is just an easier way of doing it. So like I said, you might have to watch this again to know how to do it the short way. But try doing it the long way the first time, and then try doing it the short way after that.
Does it matter which way we do it?
No, I really don't care. Whatever you guys are comfortable with, you guys can do. So you have time to work on